Good afternoon to one and all present here. So today we are all gathered here to attend the webinar on software testing and industrial perspective. So let me welcome our distinguished resource person, Dr. Prasanna Mani. He has completed his MS in Computer Science and Engineering from Anna University. He received his doctorate in software engineering from Anna University. Currently, he is working as professor, School of Computer Science and Information Technology Engineering, SCORE, in VIT Vellore. He possesses a teaching experience of about 20 years from various reputed colleges and universities. He published nearly 50 Scopus Industry publications in international journals and conferences. He is guiding research scholars in the area of software testing and is an eminent reviewer of various international journals. He also authored a book for cracking interview questions of C programming. His area of interest include software engineering, software testing, Internet of Things, etc. So on behalf of Department of Computer Science and Engineering, Department of Artificial Intelligence and Department of Internet of Things and Cyber Security, I wholeheartedly welcome you to this webinar, sir.
Thank you, Dr. Pramod.
Okay.
I
Next,
would like to thank Dr. Pramod Matthew for providing this excellent opportunity to address all of you in virtual mode. I would like to thank our principal, Providence College, also for accepting and permitting me to give this guest lecture on software testing. And I'm very happy to meet all the students. Today, I'm going to share some of the knowledge that I have gained in software testing, which is very much very interesting field. So I'm also guiding all the research scholars only in the area of software testing. So today I'm going to share some information about the software testing methodologies and the testing tools that are used in IT industry. It may be very useful from project point of view. So many of you would be doing project either in the third year or fourth year time, so you can apply all these concepts for any type of projects. So that is the advantage of software testing. So now I'm going to share the PPT slides, and I'm going to explain all the things that are mentioned in the slide. Okay, I will share the slides now. So whether the slide is visible? Yeah. Okay. So now let us dwell upon what is software testing, how interesting it is, how it is different from the developer problem statement. Usually it will be given by the customer. It can be in the form of bullet points, or it can be run into several paragraphs. So from this problem statement, so we need to apply the various requirements elicitation techniques to understand the requirement properly, because once you understood the requirements, then all the process are made easy. So we can use very latest techniques for capturing the requirements. So you can go for more than one combination of the requirements elicitation techniques to understand the requirements. Sometimes, if you talk everything verbally, customer may not be interested. So what you can do means, so you can go and construct some simple diagrams, and you can express to the customer that these are all the functionalities that I'm going to provide in the software, so that the customer will have clarity about what you're going to deliver, because it is going to consume approximately 20% of the development life cycle cost. Okay, so 100% cost we can split it into different stages. So in the requirement analysis alone, so we are going, all the IT industries, they are spending around 20% of the cost. So the outcome of the requirement phase is called as SRS document. So SRS document stands for Software Requirement Specification Document. It contains full information about what are all the functionalities, what are all the modules, all the things. Okay, so this SRS document plays a pivotal role from testing point of view. That is why I'm telling, because we need to commence the testing process parallelly with the development. So that is our goal. So we need to understand the requirements. So SRS document knowledge is very much required from the tester point of view. And then afterwards it goes to the design phase. So design phase takes the SRS document as input. They construct different type of diagrams, high level diagrams, low level diagrams, and the output is again a form of document. So the
Sir,
document is software.
excuse me,
Yes.
sir.
Yes.
Sir, still it is showing the agenda slide.
Okay, fine. Okay, fine.
Okay, sir.
So
Yes, sir.
yeah, I was talking about the software design document. Software design document is outcome of the design phase. So in the design phase, also 20% of the cost is spent by the IT organization. Then afterwards, we won't give the design document directly to the coding team because the coder does not have knowledge about the diagrams. It is not mandatory also. So coders, they are good in Java code or they are good in Python code. There is no compulsion that they should have knowledge about all the design diagrams. So this software design document comes as an input, and then we have to generate something called a pseudocode. So pseudocode is given to the development team, so from which the developers, they will write the business logic functions. Okay, so these are all very much required from testing point of view. That is why I'm giving some information about all these things. Okay, and once it goes to the development team, so they convert those pseudocode into actual code by writing the business logic functions, and then they execute the files, and then they are confident that the software is error free software. Then it goes to the testing phase, right? So this is how the testing field is connected. So you need to depend upon the deliverables of the software development process, then only you can commence the testing process. And then coding also, approximately 20% of the cost is spent. Okay, so now 60% of the cost is spent on all these activities. Okay, so 20% for requirement, 20% for design, 20% for coding, and then remaining 40% of the cost is spent on testing. So that is what I want to emphasize. More the cost is spent on the testing and maintenance phase. Okay, it is a very crucial phase. And then testing is done by two different type of people. Okay, one is developer. So the developer once writes the logic, and then the developer will be testing that. So we call it that as white box testing. So white box testing is applicable for developers who write the code. So today I'll give demonstration also how to do the white box testing using the tool. So I'm going to share a tool called as JUnit tool after the end of this presentation. Okay, so white box testing is carried out. Then if the developer is confident, then the software exe files and dll files, only these files are shared with the testers. Okay, so the tester, they will not see the source code. They have to understand the functionalities of the system from the SRS document. Okay, so that is where the testing people have a lot of things. Okay, so it is not an easy task. So developer, they will be able to see the code, they can rewrite it, but the tester is not allowed to see the code because sometimes the testers may be intelligent coders. So if you allow the tester to see the code, they will modify the code, and they may cause some problem. So we need to avoid that. So this is the thing we need to understand. So testing is commenced parallelly with the development. So you may be wondering that, so the testers will be idle, correct? Because SRS document has to be prepared, software design document has to be prepared, coding has to be completed. After that only the testers are coming into the picture. That is the myth actually. Testers are not at all actually ideal. Once the requirement capturing process is over, tester, they will start the testing related activities. So that is what I'm going to cover in the next slide. So these are all the various fields that are almost used by IT industries. They develop the software, they maintain the software for a longer period. So approximately 10 to 15 years. So these applications are maintained. Only difference is technology will change. So accordingly, you have to rewrite the code, and you have to redesign the test cases, and you have to test it. Okay, banking, insurance, healthcare, and then information management, life sciences. So many softwares are developed, and then these softwares, they'll get more benefit for the organization if you maintain that software for a longer period. Now let us see about the testing life cycle. This is a very important thing. So I talked about that SRS document. So you can see here requirement analysis phase, the outcome. So take the SRS document, start your test planning phase. Okay, so test planning phase, you have to plan a lot of activities related to the testing. Say, for example, you have to calculate how many test engineers are required, how many test leaders are required, and how much time is required to test the application. And then you need to keep the test cases ready. Okay, that is the main thing to be noted. because from the SRS document you would be able to collect all the information, right? A to Z information is available. So we need to say, you can ask one question. Suppose the tester is not able to see the code, then how they will design the test cases? So the answer is very simple. In the SRS document, user interface screens are present, right? So you have to understand the functionality of the application, first thing. So you need to have knowledge about how the business rules are applied on the given modules. So you need to understand that properly. Then you have to write the test scenarios, and then for every test scenarios you have to write the test cases. So according to the number of test scenarios and the number of test cases, you can predict how many test engineers are required to test the application. Okay, so that is the next phase. Test plan phase is it is equivalent to SRS document. So you might be knowing that SRS document is prepared by project manager, right? So similarly, the test plan document is also prepared by a person called as test manager, equivalent. So in development side, you have three important people: project manager, project leader. Under project leader, various developers will be working and they will be writing the code, correct? So on the other hand, testing side also, we have three hierarchies. On the top, we have test manager. Next, we have test leader, and then bottommost test engineer, and then still bottommost is called junior test engineer. So these four hierarchies we have in testing side. So equivalent opportunities. Project manager will be getting around 3 lakhs per month salary. Test manager is also getting equivalent 3 lakhs per month salary, right? Nowadays, there is no difference between testing and development. So equal opportunities are there, and then a lot of advantage you have in testing side also. If you take the, I'm not against the developer, okay, just I'm telling there are a lot of opportunities available in the testing side also. Okay, that is my intention. So another advantage is coding field frequently changes, so new languages are coming up in the market, lot of frameworks are emerging, new technologies are coming up, so you have to upskill yourself, right? Whereas testing, it is not required like a development side. So only thing is you need to understand about the new format of the test cases, because applications are nowadays changing a lot. Okay. So test plan document contains A to Z information about how you are going to carry out the testing. Okay. So it is prepared by the test manager. It runs into several pages, 30 minimum 20 to 30 pages you have to write. It also talks about when to start testing, when to stop testing, what are all the deliverables, what are all the testing methods you have adopted, and then what are all, how the results are written, and finally how many bugs you discovered in the testing process. This is the main thing, right? Developer is also testing, tester is also testing. What is the difference? So you may ask this question. So the question is, you might be knowing that developer always have constructive mindset. Okay, they never think negative. Whereas tester, they should have destructive mindset. So whenever you are testing an application, you should have a mindset that this application has got 100 logical errors. So I'm going to find out all those 100 logical bugs through my test cases. This should be your attitude. Okay. And another important information is software developers, testers, they will not see face to face. Sometimes developer may be sitting in North India, tester may be available in some abroad countries also. So people working at different places, they'll be doing the testing. So they will not be meeting in person also. Okay. So you should have this thought, and you must remember that you are not going to criticize the code developed by the coding team. So your objective is you need to see that the software does not crash even during extreme input condition. That should be your goal. Okay. So you need to see that all the critical functionalities are tested properly, right? So from the test plan, all the test cases you have to write it. So here comes the black box testing. So from the title itself, we can understand that black box testers does not have knowledge about the code. They do not know the internal structure of the program, but they need to predict what are all the inputs, what are all the outputs. So based on that, they have to adopt different strategies to design the test cases effectively and efficiently. That is what important. Okay. So you cannot design test cases randomly. So because you must also know that testing time is very less, development time is always more. Say for example, 10 days is given for the complete software development, 8 days will be consumed by the development team, only 2 days it is consumed by the testing team. So imagine the importance of testing. So the tester should not wait unnecessarily until the code is released. So as soon as the SRS document is prepared, you can do your testing activities. And please remember that testing means not finding fault only with the code. So there may be some error in the SRS document. Some say, for example, some requirements may be redundant requirements, or some requirements are inconsistent. Okay, so you can inspect those documents also. So testers have got full authority to inspect all the documents that are produced in the software development process. So if there is a flaw in the SRS document, it can be informed by the testing team. The relevant people can change it. Similarly, if there is a design error, so that can also be pointed out by the testing team. Similarly, coding, you do not have knowledge. Only thing is you can suggest some good data structures. Advanced methods called as static testing methods are there. So during that time, the entire code will be shown to the team of experts. They can give some suggestions, they can alter it. Okay. So this is the main difference. So you must understand that you are not going to catch only the coding related faults, logical faults. So you need to find out what type of error. So that is why it is always said that try to catch the error as quick as possible, right? If you propagate the error to the subsequent phases, then cost of fixing that error would be enormous. Say for example, in the requirement phase, if you catch the error, the cost of fixing it would be 1 rupee. Okay, suppose if the product is released and after that you are fixing it, the same error for fixing it would cost around 100 rupees. So it multiplies 100 times. So you have to be very careful about catching the bugs. And then you need to see that the software always works in the client side after it is released in the market. Okay, so the test cases plays a pivotal role in identifying those logical errors. So the test environment, so that means, so testing nowadays, it can be done in two different modes. One is manual testing, another one is called automation testing. So we need to certain test cases, we have to do it manually. That is unavoidable. So when I was speaking with some of my alumni students, they were telling that 80% of the test cases are executed manually in IT industry also. Only 20% requires automation. Okay. So if you want to automate the work, then you need to install the tool, and then you need to check that whether the tool takes the sufficient input and the results are nicely projected by the tool automatically on the screen. So all these things comes under the test environment setup. Okay, and next thing is test execution, recording the results. So three reports are written as outcome of the test execution process. One is called as test log report, another one is called as test incident report, third one is called as test summary report, right? So from this report, so this report will be shared with the development team. Please understand that. Okay, so because I already told these two people, they will not see face to face. So we have to write the reports in a professional manner. So in that report, we have to record the snapshot of failures. Okay, so that the developer can understand the impact of the bug. Okay, so the bugs may be classified into different categories. So they may be called as a critical bug, or they may be called as major bug, medium bug, minor bug. Okay, so first of all, when you share the report, the developer will have curiosity about seeing the impact section. In the test log report, there is a section called as impact of the bug. So if they see it is a critical bug, then they need to fix it. Suppose if it is a minor bug, say for example, alignment may not be proper. So those type of errors can be fixed in the next version, because nowadays agile technology, agile frameworks are used. So you can fix those minor errors in the next version. So this is the life cycle. So the requirement analysis phase, and finally the test reporting phase. And you need to understand that this process is iterative. Until the bug is taken out of the system, this process is iterative in nature, right? So this is the test life cycle. So now I'm going to show you a single bug. So it undergoes different state changes. You can see that in the next slide. Sorry. Okay. So that is not there. Okay, fine. So yeah, this one, life cycle of a bug I was talking about. So all these rectangle boxes denotes the different states a bug undergoes. Okay, so new state, whenever you are identifying a new bug, okay, so you are going to change the state of the bug as new, and then it will be verified by the test leader. Okay, because they have to check the genuinity of the bug. So sometimes your understanding may be different, actually that may not be an error. Okay, so you cannot simply blame the development team, because whenever you are confident that yes, it is a logical error, someone has to verify that it is a logical error. someone has to approve it. So that is what done in the second state called as assigned state. Okay, so after that it goes to the open state. Yes, now the developer has understood that yes, it is a critical error. Okay, so they will find out which team has developed that error, and then the team will work on rewriting the code. Okay, so to eliminate that bug. Okay, by reading the snapshot they will understand, oh, this is the problem, so we need to modify that. So they will rechange the code, and then again they will test it. Okay, so this is iterative process until the testing team gets satisfied result. Okay, so they will keep on telling the developer to rewrite the code. So during this process, so there may be some reasons like duplicating the code, that is also possible. So in that case it goes to the closed state. So initial state of the bug is new, finally it should go to the closed state. Sometimes the bug may not be accepted by the development team. In that case it goes to a rejected state. Okay, sometimes the development team may not have sufficient time to fix the bug, so because that is a minor error, so in that case it goes to deferred state. Okay, it will be fixed in the next release. Okay, so these are all the different states a bug undergoes in its life cycle. And then these states are operated by test engineers, test leaders, project leaders, developers. Okay, so whenever the change is made, so nowadays with the help of in-house software, all the bug states are monitored and then changed accordingly by the development team as well as by the testing team. So this is how I'm talking about a single bug. Okay, so single bug undergoes this much amount of state changes. Imagine if you have caught 50 bugs. Okay, so each bug will undergo this type of state changes. So whoever is responsible, they will alter the states of the bug, and accordingly it will be notified to the concerned person for correction. Okay, and then again we need to test it. Finally, once you are satisfied, you can say yes, this bug is verified, fixed, close it. That's all. Okay, now our objective is we want to give the error-free software to the customer. So that is our goal, right? So as far as functional testing is concerned, so these are all the various testing methods that are applied on any type of project. Okay, so you can say acceptance testing. So acceptance testing is always done by the customers. So once the customer install it, and then it should be in operation phase. Okay, so the customer will be doing this acceptance testing. Alpha testing and beta testing will be done, and then integration testing, again lot of test cases. First we have to start with unit testing. Okay, so whenever a module is ready, you can do for unit testing. So this is always done by the development team. So today I'll give a demonstration also how to do unit testing. There is a tool called JUnit tool is available. So I'm going to share a Java source code, and I'm going to teach you how to run the JUnit testing tool, and how the results are nicely tabulated in a report form. That I'm going to give demonstration. Unit testing, and then after that integration testing, integrating the modules. So unit testing you require different type of test cases. Integration testing you require different type of test cases. And then system testing. So system testing means all the modules are integrated, coupling and cohesions are checked, and then now the whole system is ready for usage. Okay, and during this type interface testing can also be done, UI testing. So this UI testing can be done by a tool called Auto IT tool. Okay, that is a open source tool. So you can make use of the tool, and you can record the actions of the customer, how the customer is using the software. Okay, so you can record it, you can replay it, so you can observe the user activities, and accordingly you can check. Suppose if one or two components are not working on the web pages, it can be corrected by the development team. Okay, so that is one type of things called as interface testing. Regression testing means, say for example, some requirements will be changed by the customer after some point of time. Okay, so in that case you have to rewrite the code. So you have to redesign the screen, new functionality should be added. So after that the existing test cases should be rewritten, because now the new inputs may be added on the screen, so you have to rewrite it. So that is called as regression testing. So regression testing is unavoidable nowadays, because requirements need to be changed by the customer once it is in operational. So we cannot deny that I will not change it, because customer is paying the money. So we need to respond to every request given by the customer. Okay, and then there is a two interesting technique you can see on this slide. One is called as sanity testing, another one is called as smoke testing. So smoke testing, first let us discuss about that. So smoke testing is nothing but once the software is ready, okay, so you need to check that all the critical functions are working properly or not. Okay, that is the main thing. Say for example, you are testing an ATM website application. Okay, so critical functions are nothing but withdrawing the amount, depositing the amount. Okay, so you need to check that these two functions behaves properly and dispenses the cash according to the user input. So that is called as smoke testing. So this is also end-to-end testing. So this is called as end-to-end testing, smoke testing. So next is sanity testing. Sanity testing is subset of smoke testing, I will say. Okay, so that is the main difference between the smoke test and the sanity test. So here you may not have sufficient test to the sufficient time to test the entire application. So what you can do means you can take one or two subset of the given application and test it and see that whether it works properly or not. So that is called as sanity testing. So this is the prime difference between smoke testing and sanity testing. Okay, so these are all the different types of functional testing I'm talking about. Non-functional testing is also very much used in IT industries because that will determine the performance of your application. Okay, so now let us see an example. Let us take a banking application. So let us say you are going to test this bank application website. Okay, so you can see all those things. So everything is crystal clear, the images are proper, and then color combination is also good, and you can see the login screen, so with user ID and password. Let us assume that you are going to test this application. So I am a black box tester, so this website has reached my end. So I need to design the test scenario for this application. Okay, let us see how we can design the test scenario. So simple test cases I'm going to show you. So login test case. Okay, so we need to create test scenarios for this application. So in this slide you can see three test scenarios I have written. So first one is login details. So first I need to see that I'm able to log into the banking website, launching the website. First I need to test it. That is first scenario. And second is user authentication. So when I type the username and password, I need to say that one time password should be received in the mobile phone. Okay, this is the first time I am going to use it, so I need to verify that. And then the remaining things are cash deposit and cash withdrawal. So three test scenarios are applicable for this banking application. So this is how industry is also making it. So you need to write what is test scenario, write brief description about the test scenarios, and then for each test scenario you have to design the test cases. So this is the result and test metrics table. You can see I have designed three test cases, very simple test cases. Nowadays IT industries, they are writing all the test cases in descriptive form because nowadays people are moving from company to company, so your work should not be disturbed when you quit the organization during the midway of the project. So you must provide proper explanation. So this is the first one, TC001, to verify user able to perform banking login. This is the actual result. This is the expected result. Okay, so when you type the URL and when you type the username and password, it should check with the database, and if the login name and password is correct, so it needs to be you need to go to the subsequent screen. So this can be tested by some other person. For understanding purpose I am telling. Okay, so second one is, this is for one time password received on the mobile phone, and then this is also expected. So you have to compare this expected results and the actual result. Okay, so if there is any difference between the expected result and the actual result, then you can say the test case is failed. Okay, if both the results are same, you can say the test case is passed. That means that functionality is working nicely as expected by the customer. Okay, so you have to record all the testers name. So this is how the test cases are designed by the IT industry. Clear? What is test scenario? What is test case? So identify all the test scenarios. For each test scenarios, design the test cases accordingly. So here you have to make use of different black box testing methods to test the functionality. Okay. So this is the test execution part. So I told about one simple function. So you need to understand the whole application because the business rules knowledge is very much required. So understand what are the primary functions of the bank, what are the secondary functions of the bank. So you should have full knowledge about the entire banking process. And then under primary functions, you have to test all these things: accepting deposits, These are all the four modules you have to test under this. And granting advances, these are all the four modules you have to test it. And then agency related functions, these are all the modules. Utility functions, these are all the modules. Okay, you have a lot of scope. Now you can see several modules are there. So each module should be connected also. Okay, they are not standalone modules. They need to be interconnected with each other. So you have a lot of scope for integration testing and system testing as a whole. So three times you have to design the test cases. One is during the unit time, each module test cases should be designed. Integration time, again, based on the parameters, you have to design the test cases. Sometimes during the integration time, one or two modules may not be available, okay, due to non-availability of the development side. In that case, you have to create dummy programs. So we call it as stubs, drivers and stubs. Sometimes main module may not be available. You have to simulate the main module, okay, and integrate and test whether all the modules are able to pass and receive data from the main function to the sub function, from sub function to the main function. Like that, you have to test it. Once the actual code is available, you have to replace it. You have to replace the dummy code, but extra cost you have to bear it. That is unavoidable, because once you complete the application, no need to wait. You can switch on to other projects. Clear? Right, so I already talked about the defect management. You have to store all the test cases in a repository, because you can reuse the test cases. Okay, don't think that only coding reusability is possible. Reusing the test cases is also possible. Okay, so because login, password, all these things that are all common for any type of web application. So don't waste your time in rewriting the test cases for these basic functionalities. So you have to store, you have to plan, and you have to store all your test cases in databases. So you can see the DBMS concept also plays a very important role, managing all your test cases in a nice manner. So testing is integrating all the subjects. Okay, and I already told about the defect reporting scenarios. So I already conveyed that. So I will not talk about that. So nowadays, agile testing is taking place. So you all know that quick development time, 3 weeks once we have to give the functionality to the customer for usage. So certain terminologies are there. And then what I understood from this agile testing is nowadays in the agile framework, they are not at all using even life cycle models also for the software development. Each one is responsible for creating the code. So same thing. So here the requirements are called as story points. Okay, so you will be given some stipulated time. So as a developer, you have to write the code and they have to deploy that. Testers, they have to test the application within 3 weeks of the development time. Okay, and the defects will be reported to the developers. Automation also possible, but very limited time. So you have to nicely plan, then only you will be able to apply the automation part, because automation saves lot of work. And then certain activities you cannot watch continuously for 24 hours also. You need to give the task to the computer to monitor all the activities that are taking place. Okay, say for example you are testing a network related project. So in that case, continuously the log files will be pulled from the server to the client and vice versa. So if you want to observe all those packet movement information, so it can be done with the help of network testing too. Okay, so that is the advantage. So this is the overall idea about the agile framework. And then so when you are designing, this is how the test designs are happening in agile framework. Also you have to design positive test cases, negative test cases. Positive test cases means, so you can also see the prerequisite for test cases also. This is also applicable not only for development. So in order to test the login, you must have a valid user account. That is a prerequisite. Okay, and then post request means automatically it goes to the subsequent pages and you can do all the other functionalities. And then you have to prioritize these test cases, whether it is critical, medium or low. That also you have to give test priority. Okay, and this is the test metrics table. So it shows how the test execution steps are happening. Okay, so we have to launch the application, see that it works perfectly in different browsers also. Okay, and then first you try with correct password, correct username and password, see that it is going on properly. And once you hit the login button, this happens. Okay, either you can hit the login button with the mouse or with the tab also, right? You have to test it. So the tester job is not writing the code, they have to test it. That's it. Okay, so this is how the positive test cases are tabulated. And this is the negative test cases. Give invalid input and invalid password and observe the behavior of your system. Okay, so our ultimate aim is we need to see that the system give some error message, even some if I give some incorrect input. So that is what the main goal of testing. It should not go to restart, it should not go to hang state. So you should give some message. That is what expected. That is what testing is all about. So you design number of test cases according to the application inputs. It varies from screen to screen, and these are all some of the tools that are widely used in IT industry as well as by the student projects. And then, so the cost of the testing tools are slightly expensive, but sometimes customer feels that, if you use the licensed software, the quality will be guaranteed. Okay, so these are all from HP. ALM is a product. AdPod is from CTS, and then Selenium is a open source. You can also use. UFT is also a famous tools. So these are all test execution automation tools. Say for example, you can create 10 login IDs, 10 password, and you can store it on a file. You can give that file as an input to the Selenium tool. The Selenium tool, it will take one test case from the file, it will execute, you can record the action. So in that way you can check it. And then these are all the tools that is applicable for defect management, storing that. Jira is famous. And then performance testing tool. So due to lack of time, I am not able to concentrate on this one. So load runner and wind runner, these are all popular tool. So JMeter you can also use it. And then for integration tool, you can use Jenkins. Okay, so these are all the common testing tools that are used, and these are all the screenshot of these tools. So nowadays all the things can be managed by the tool. Okay, so you can see who created. So you can see test plan. So just click on this test plan, the template will be displayed. So you can fill the respective sections. Okay, so in that way job is made easy. Like MS project. So this is a life cycle management tool, comes from HP Corporation. This is AdPod from CTS. Okay, so these are all the advantages of automation. Okay, so I talked about manual testing. So you can execute 100 test cases in 1 second or 2 seconds. That is also possible. Okay, so this is the Selenium test automation framework. This is an open source tool, so you can learn by yourself. Very easy to use. So this is UFT automation tool. So this is the defect management tool. Screenshot I'm telling. Performance, I talked about JMeter. So this is load runner tool from HP. So it costs around 1.5 lakhs. Okay, this tool. So you can reuse for many website based applications. So this is for integration tool. Jenkins, very popular. So I talked about all these elements, software testing, and then types of testing, all those things. Okay, so I want to give one practical example also. Afterwards I will take one questions from your end. Okay, so shall I move on to the demo section, Dr. Pramod?
Yes, sir, sure.
Okay, fine. So I'm going to give demonstration about a tool, the JUnit tool. So this is used by the developer, not by the tester. So you can see, first of all, you need to understand that in IT industry, 100% testing is not possible. Okay, only critical section of the code they will test it and they will release it. Okay, so this is the main thing. So let us consider this Java code. So employee details. So it has got certain member variables. Okay, name, monthly salary, age, name, all those things. And then there are functions for assigning the name. Set name function, get name function returns the name. Like that, some simple functions are there. Get monthly salary, set monthly salary, and then get age, set age. See, please understand that we are not going to test these elementary functions through our test cases, because that is the basic responsibility of the developer to code these functions properly. So our task is to check whether the business logic functions works correct or not. So what I will do means I will segregate non-business logic functions and business logic functions. So I'll write another class called employee business logic class. So this class contains two important functions. So for demonstration purpose, this function I'm going to use. So because it involves some amount of computation. So I return a function called calculate yearly salary. It takes object as an argument and then that is multiplied with 12, and this function returns the yearly salary. Okay. So I need to check whether this business logic functions works correctly or not. Okay. So next function, appraisal function. Calculate appraisal. Again, this function also takes as object And if my monthly salary is less than 10,000, this appraisal amount is set to 500 rupees, else it is set to 1,000 rupees. Okay, so as a tester, the Java developer, I need to test these two methods. I need to pass object as an argument, and I need to see that this function returns a correct result or not. So after writing this code, I need to save this file. Okay, so the function which has got business logic, I'll be storing that. So already this code I have stored that. So first you need to set the Java environment. Whether the screen is visible? Command line prompt screen.
Yes, sir. Visible.
Okay. So just now I shared the code, no? So type m business logic.java. Just now I explained this code. The same code I stored in this particular location on my laptop. Okay. So I need to run the Java code. So I already used the path command to set the path. Okay. So that I can execute the Java C and Java compiler. Okay, so now I need to create class file for this Java C M business logic dot, because I need to check whether the program is error free program or not. After that only I can write test cases and I can pass value to this business logic function and I can check it. So the program is error free code. You can see that DAR E star Java. So you can see today's date, the class file is compared 29. Okay, sorry. Yes, so you can see the last file, test employee details dot class 15/11/2023 7:31. Okay, so I created this file. So now you can see the other two files, so 2042. Just now I created this file, class files are available. Okay, so next step is I have to write the test script. That is the main thing. So the program is ready for testing. Now I need to write the test script. Okay, so I'm going to use JUnit for this purpose. So like Java code, you have to write the test script junit.framework.test case. T and C are case sensitive. So this test case class contains numerous methods for testing the application. So like Java code, I'm extending the test class. I'm creating object. Just now I created a class. I created two objects, one for employee business logic, another for employee. So this is the method. So I am testing the appraisal method. Public void test small letters calculate appraisal. So this method only I am testing. So mandatory I need to write test, and which method I am testing, that also you have to include. Employee dot set name Rajiv, age 25, monthly salary 8,000. So I am passing this to this function employee logic calculate umbrella. So actual result is given by this function. It is stored on this variable, and this is assert equal methods. Compare the expected output with actual output. So actual output is stored on this appraisal method. So this function, because my monthly salary is 8,000, no, if it is greater than 10,000, then appraisal amount is 1,000. So if it is less than 10,000, then appraisal amount is 500. So I'm checking whether the function gives 500 or not. So the last one is for delta, that is for dealing with floating point. So similarly for yearly salary also, you can see here. So 8,000. So second method I'm writing test calculate yearly salary. So I'm setting the basic details about the object. Then I'm invoking this business logic function. So this function returns the result. Again, this is compared. 96,000 is the expected result. Actual value is returned by this function that is stored on the variable salary. So, okay. So now the test script file is also ready. So I have to run this test script file. That is the next step. So I will show the test script file also, DAR. Okay, so test employee details. So just now I was explaining the code. The same code I'm going to execute that. Okay, just now I explained this code. So I need to compile this code. So this code should not have any errors. So I have to. Mm, yes. Okay, test employee. Yes, this file is also successfully compiled. Now I want to see the test result. So I wrote only one test case. This appraisal assert equals methods is nothing but the test case. So one test case for appraisal method, one test case for calculate yearly salary method. So two test cases are executed. Now let us see invoke the uh, output. Okay, so that is called as you need to let us see the output. So Swing user interface is developed for this. Yes. So Swing, already you might be knowing about the concept called Swing. So it is based on that this test runner and then this test employee details. So you have to give this class file as an input to the test runner tool. Okay, and we can see the output on the screen now. So now only we are executing the file. Previously compiled, got the class file. Then now I am invoking this test runner interface to see the test case results. So after that, just give so you can see this screen. Are you able to see the screen? JUnit in
Yes, sir.
green progress bar, green progress bar. Is it visible? Yes.
Yes, sir.
Okay, so when you click on this test hierarchy, you can see the two tick marks. One is against the test calculate appraisal method. Another one is test calculate release salary. So both these methods are tested properly. So that means the expected output and actual output both are same. So you can see how much time it took for executing these two test cases. Similarly, you can write 100 test cases, give that to this tool. So